Assalamualaikum warahmatullahi wabarakatuh. My name is Nurusna.
My name is Asha Mediha binti Mustafa, and we are going to present about reused plastic as 3D printer filament for our case study.
In this modern world, manufacturing is one of the significant areas to generate incomes and improve the economy of the country. Manufacturing is the medium in order to serve the demand of the community and enhance the socio-economy because it will serve their consumer by producing the merchandise for the use or sale using labor, machine and other that are related to it. But this activity is commonly applied to industrial production where the raw materials will transform into final end product on a wide range scale. So, in order to manufacture a product, most common method that manufacturers use are additive and subtractive manufacturing. Additive manufacturing is a process which the constructed 3D project that were designed by CAD will be constructed by successfully depositing material in layers. As for subtractive manufacturing, the desired 3D object will be constructed by removing or cutting the material away from the solid block by using some particular machining process, for example, milling or turning. So in this project, the focus is on the additive manufacturing, which it will be fabricate the product. So what is additive manufacturing? Additive manufacturing is also known as a 3D printing. It's a process which can turn a design into a real three-dimensional object. It can make any object regardless the complexity of the pattern, and the fabrication of the product will be accurate due to this advanced capability. This technology has been broadly used and continue to expand its scope and capable to serve according to desired demand, especially to product developers and manufacturers. This technology is simply design the model by using CAD, and later AM will express this design into a series of simpler 2D shape. The object that will manufacture can be in any shape or any geometry, and usually were produced by using digital model data from 3D models such as AMF. And the most common used type of file is STL, that is stereolithography. So this is the basic step in order to produce the product that is designing. This process later will continue by deposit a binder material into the powder bag. We inject heads layer by layer until all the part is complete by combining all the layers. So the major application areas that are widely used this technology are for example aerospace, automotive, medical and many other industry sectors. Actually, there are a lot of 3D printing method that can be applied to fabricate the product. For example, SLA, that is stereolithography, digital light processing, other name is DLP, and FDM itself. But we are choosing FDM because it is one of the popular method, and our project is focusing on the filament. Only this method, that is FDM, is using filament, and the rest, for example, for SLA and DLP, are using liquid or other than filament itself. That is why we choose FDM. Okay. FDM will not only fabricate the functional prototypes, it also can print the concept model and final end use product. And by using this method, all printed parts by FDM can go in high performance and engineering grade thermoplastic that give the benefits to mechanics engineers and producers. So, in order to attain a high performance finished product, some major concerns need to be taken into account. and some characteristics should be focused to get the ideal and the best 3D printer material, considering the environment issues, cost, mechanical properties, surface finish of product, and optimization of the material. So the printer filament itself is like the ink to the printer. So printer filament is very important thing. To produce the product that is a high, just like I said before, a high performance finished product. So basically material that are commonly being used are PET, ABS, nylon, and PLA. And this material is currently sold by the traders, and we can buy it conveniently in the nearest store. So this is the table which the PET, PLA, ABS, and nylon, and shows their differences. For example, the temperature itself. For PET, the print temperature is between 220 and 250. For PLA, 180 until 230. ABS is 210 until 250, and nylon 240 until 260. The temperature itself play the important roles in order to get the good quality of the printed object. Okay, this is the end product of PET, PLA, ABS, and nylon. We can see that different texture based on their properties of the material.
So so next, why are we coming with the issues of 3D printer reuse plastic as 3D printer filament? Is because the two alarming issues, which is the cost and about the issues of saving the earth. We can see, according to the CNN Tech, the 3D printing ink is way too expensive. This 3D printing ink is referring to the filament. And then, according to the Independent, the issues under the environment is why we need to recycle plastic and not add to the 8 million tons of rubbish in our oceans. Hence, recycling, reusing back the plastic is crucial to save the earth and the oceans. Under the according to the Guardian, the existed sustainable bioplastic that are produced to help the issue of the environment also can also have the ability actually to damage the environment.
As we can see, this is different 4 different types of PET, PLA, ABS, and nylon. For PET is on 110, PLA 65 until 110 ringgit. ABS is for 63 until 100, and for nylon is 124 and 280. This is all for 1 kilogram filament, which is, I think, it is too expensive for this their mass.
Actually, there are two types of plastic or polymer in the chemical language, which is thermosetting and thermoplastic. So here we are going to emphasize the 2 points, the differences between the thermosetting and the thermoplastic. So the thermosetting happens because it have the cross-link forming, which is it is the irreversible chemical bond between the element. And then for thermoplastic, there is no cross-linking happen, and then it can be completely reversible chemical bond. So that is why in thermosetting polymer, it have the characteristic of high level dimensional stability, which is usually used in electronic devices such as televisions and so on. And then for thermoplastic, it can be easily remolding or reshaping. So that is why the thermoplastic polymer usually used to be recycled. So the example of the thermosetting is the epoxy. We have polyester, vinyl ester, and then for thermoplastic we have polyamide, PA or nylon. we have polybutylene terephthalate (PBT), and then we have polyethylene terephthalate (PET) as polyester. So the PET is usually used and then commonly used in this whole world. And then the example of the PET product is the plastic bottle. In recycling, we have to identify each of the different type of the plastic. There are 7 classes according to the ASTM, and it can be identified by each of its resin identification codes, or RIC. So we have polyethylene terephthalate with logo 1, we have HDPE for number 2, we have polyvinyl chloride for number 3, and etc. So each of these plastic product can be identified by the logo or the number code at the bottom of the product. Talking about the recovery utilities, actually in the government of Malaysia, under the Department of Environment Malaysia, they have hired recovery utilities that can transform and cure the plastic, mainly the plastic waste, into other product or new product, either it is in a raw material or in a finishing product. So here is the steps in making filament. Actually, it is a common step. Either it is using a recycled material or a new raw material. So first, if we are using a recycled material, first we have to remove the dirt, and then remove the water, and then it will be dried in the vacuum machine. So this is important. Or if there is a water or dirt in the recycled wastage, then it will influence the surface finishing or the quality of the filament. So next we have the shredding. The shredding is important so that the recycled wastage is shredded into similar and uniform size, so that it will ease the extrusion process. So in the extrusion process, the recycled wastage is melt, and then hence when it is extruded, they will be cooled and then spooling, and then the process of the designing, and then the usual 3D printing proceeds.
Actually, there are many types of extruder that are available in the market, but these 4 are the commonly used. Those 4 are Nostec, Filament, filler extruder, and Filament. But in our project, we are focusing on Filament because it can be used. It can use plastic bottle as a raw material for the filament, and this technology allows a high consistency in the diameter of the filament extruded. This is the example of the simple extruder done by IDP project student, and basically they have 4 major parts, that is heat system, circuit control, feeder, and motor. Here, there are 4 types of shredder, that are filmmaker, filabot, cruncher, and DIY. And these 4 types will shred different material according their purpose. For example, the filmmaker is designed to shred the recycled material.
So in our example of case study, by the 3D hubs, they used their old 3D printed model as their recycled material, and then they are shredded by the filmmaker, which is famous and commonly used to shred 3D printed old product. And then the recycled material will be shredded in stages to produce uniform particle size to ease the process of the extrusion. Okay, in this example of case study, the distance between the fan and the extruder is important for the cooling process, because it will influence the parameter of the filament, which is the weight of the filament and the diameter of the filament. So here we can see the surface finish and the properties analysis of the 3D printed product. So on the left side we have the new pellets versus the fully recycled, and then on the right side we have the new versus the old PLA filament. So we can see here that even using the recycled material, actually the quality of the 3D printed product actually is the same. And in terms, if the product is important in terms of the quality, in terms of the quantity, instead of quality. Hence, the recycled material filament can be used. The stress strain curve and the ultimate tensile strength test also indicates that the quality and the mechanical properties of the recycled material also have the same quality to the new product of the 3D printed filament. So here we have the recycled filament process done by the Perpetual Plastic Project. After the plastic is washed and then it was dried and then it is shredded in stages. As we discussed before, the recycled material is shredded in stages until it achieves the uniform size of particle. And then the next stage is extrusion of the filament. And then the last step is the 3D printing, which is the common process either for the new filament or the recycled material filament. For the sources of the recycled material in the Better Future factory, they are using plastic bottles and even old dashboard from the old car as the source of the recycled material for their filament. As the conclusion, the issues or the problem statement for our case study, which is the reuse plastic as 3D printed filament, can be solved if each one of us recycled and reduce the usage of plastic in our daily life. Besides, authorities or the governments have to focus on recycle, not only reduce, to produce a better and a green world to sustain for our next generation.